So we covered a few questions on wave functions in the previous video. What I'm going to do in this one, work you through the solutions. You can have a look at these and see how you got on, check you're working against them in your answers. So just a quick refresher, these were the three questions I set you in the last video. So the idea was to be able to write any of these three equations in a wave form. We have to be able to do that. It has to become second nature to us for making solving equations easier. So here we go. So the first one, write 2 sine x minus 5 cos x in the form k sine of x minus alpha, where k is bigger than 0 and 0 is less than alpha, less than 360. Now a question like this, the first thing you should always do is look at this and write your expansion out. You actually get a mark in a mark scheme in an exam for that. If you don't write that out, you can cost yourself one of the four straight away. So for this one, it's a k sine of x minus alpha, so you'd write it as k sine x cos alpha minus k cos x sine alpha. That there would get you one mark because you've written out the expansion and you know what you're going to be doing. It's then equating this to this. So equating that to 2 sine x minus 5 cos x. And being able to figure out where these coefficients come from. Now the coefficients for each of the terms are the k and the cos alpha or the k and the sine alpha part. And it's then matching these up. So for the sine x, we've got a 2 here, and for the sine x, we've got a k cos alpha. So I then know that k cos alpha is equal to 2. Match them up for the second one, I've then got that k sine alpha is equal to 5. Match it up with this coefficient here. That there is another mark. If you're stating these parts, you're showing where everything comes from, and they're actually going to give you credit for these sorts of things. Next thing we have to do is use this to find this alpha. Well, we know k cos alpha is 2, k sine alpha is 2. We know that tan is sine over cos. So tan alpha equals k sine alpha divided by k cos alpha, which in this case gives you 5 over 2. And this is the point where we have to use our CAST diagram to figure out where our answer is going to be. So our CAST diagram gives us one from here, and you have to look at them all. Cos is positive, so it could be in either of these. Sine is positive, could be in either of these two, and tan is also positive, so it could be in either of those two, but this is the box with the 3, so it's in this quadrant here. It's going to be in the quadrant somewhere between 0 and 90, so whatever we get by taking tan minus 1 of 5 over 2, that's going to be the answer we get. So we then know that alpha is equal to tan minus 1 of 5 over 2. Plug that into your calculator and get it, and what you get is 68.2 degrees. What we then have to figure out is the k part. Well, k, remember, is equal to the square root of these two coefficients here squared and then added together. So in this case, we know that k is equal to the square root of 2 squared plus 5 squared. 2 squared is 4, 5 squared is 25. So k is equal to the square root of 29. Now one like this, leave it as a number like this. Don't take the square root of 29 and round it. Actually leave it written in this form. Don't worry about taking it from there. And at this point we can then combine the whole thing. At this point we can then say fine. So 2 sine x minus 5 cos x equals, well, it's k sine of x minus alpha. Put in the value, so in this case we know k is root 29. It's then going to be sine of x minus 68.2. There you go. Got it written in that form. These are the key things. So when you're doing this, this gets you a mark here. This gets you a mark here, being able to show that you know to equate each of the parts. You get another mark for finding the k, and your final mark comes from finding what the alpha is and plugging the whole thing together. Typical 4-mark exam question, that's where they all come from. And you have to be able to do each of those steps. Second one was write 3 cos x minus 4 sin x in this form, k cos of x minus alpha. Again, start by expanding it. So in this case I get k cos of alpha cos x plus k sin alpha sin x. And we know then that that equates to 3 cos x minus 4 sin x. And then coefficients. That's what we're going to start to look at, the coefficients of each of them. So looking at the cos x, I then know that k cos alpha is equal to 3. And looking at the sin x, I know k sin alpha is equal to negative 4. From that, I can get my tan alpha. which I know is going to be negative 4 over 3. Again, refer to your cast diagram. Let's see where it falls. So for the cos, it's going to be positive and positive there. For the sine, it's negative, so it's in one of these two regions here, and the tan is also negative, so it's either there or there. Well, this is the quadrant with 3 solutions in it, or 3 possibilities and 3 ticks. That's the quadrant where it's in. So we find the answer here, and then we have to take it away from 360 to find it. What we then do is we do that. So if I take tan minus 1 of the negative 4/3, do it the way we work normally, do tan minus 1 of 4/3, and then take your answer off of 360, I get that alpha equals 306.9 degrees. It's then finding the k. Well, again, look at the coefficients here and square them. So we know that k is going to be 3 squared plus the negative 4 squared as well. There are coefficients. And again, the negative doesn't matter because it's a squared, that vanishes. So it's going to be the square root. 3 squared is 9, 4 squared is 16. Square root of 25, so I know that my k is going to be given by 5. It's then plugging the whole spiel together and getting what it is. So at this point I can say, fine, so I know that 3 cos x minus 4 sine x is equal to 5 cos of x minus alpha, so in this case 5 cos of x minus 306.9 degrees. Again, look at the steps. I've still shown my expansion for my first bit. I've still shown my k cos alpha, k sine alpha for the next bit. I've still shown how I calculated k, and then I've still shown how I get the alpha and what it looks like within it. Remember those key bits there. Last one I gave you was root 3 cos theta minus sine theta in this form. Now, just because I've changed the variable x to theta doesn't mean anything changes. Our first step should still be writing out our expansion. So in this case, it would be r cos alpha sine theta plus r sine alpha cos theta. And we know then that that equals the square root of 3 cos theta take away sine theta. And then it's equating the coefficients again. So we know just from reading this that our r cos alpha is equal to the coefficient of sine theta, which is negative 1, and our r sine alpha is equal to the coefficient of cos theta, which in this case is root 3. So we can then say, fine, so from that, I know that tan alpha is equal to negative root 3. It's root 3 over negative 1, which gives me negative root 3. Use our cast diagram again to be able to figure out where it lies. Well, cos is negative, so I know it's tick tick there. Sine is positive, so it's there and there. And tan is also negative, so it's going to be in the C or the S. Well, again, the S has all 3 ticks, so that's the quadrant it lies in. So again, we find our answer in the A and we subtract it. Now, the key thing to remember, we're working in radians here. Alright, so we cannot forget that. We are working in radians, so we have to make sure that we work with that. So if I take tan alpha equals negative root 3, and I look at tan minus 1 over negative root 3, calculate it the way I normally would, I can then read off that in terms of radians, alpha is equal to 2 pi over 3. Then it's finding the r. Now the r is the equivalent of what the k would have been in this case, so find it's the exact same. Square root of the two coefficients squared, so in this case it's square root of root 3 squared plus the negative 1 squared. Root 3 squared is just 3, negative 1 squared is 1, so it's square root of 3 plus 1, that's square root of 4, which we know to be 2. Then it's a case of just writing it out. So then I know root 3 cos theta minus sine theta is equal to 2 sine theta plus the alpha, but alpha in this case is 2 pi over 3. And again, the 4 same steps have been key in this. Writing out the expansion, getting your 2 r cos theta, r sine thetas, finding out r, and then finding out the alpha and plugging it in for a final solution. Make sure you include all of those steps in your work, and they're all vital to getting all the marks from a question like this.